Hello, class, and welcome to Module 4. In this module, we'll be working on CLO 1 and CLO 2. And I will read this disclaimer for you. While there are no date restrictions on your modules, focus on completing this before the fifth week of class if you want to stay on a weekly schedule. And so this video will be posted here in the Module 4 intro video. And we're going to go through the overview, objectives, and reading preparation. So the overview, students will understand primary and conventional treatment methods. The objectives are to describe methods to measure wastewater flow, examine the purpose of primary treatment, compare and contrast conventional with chemically enhanced primary treatment, assess how specific gravity and density relate to the removal of solids able to settle, and describe the difference between wastewater, stormwater, and combined collection systems. You will have two chapters to read in this module. The first is in the wastewater treatment and disposal 1, which is chapter 5, and in the wastewater treatment and disposal 2 will be chapter 1. Okay. So we move on to the next, which is the supplementary online video resources. There are two videos, one on primary treatment and one on primary treatment and clarifiers. This is going to help you get a better understanding of the process of primary treatment and a look at what it looks like in an actual wastewater plant. Then we have our module for laboratory. So this will be our first laboratory that we're working on with our kit. And for the laboratory report, as always, you want to have your introduction. You'll have your materials, a list of the materials that you have for this particular lab assignment. The procedures, you want to write that out. Your observations, this includes any data tables, observations, and any calculations. And then your discussion. So in your discussion, there are some questions that you're going to answer. You also talk about information about what happened in this particular lab. All right. There are three activities for the lab, and you'll see that there are questions that you're going to answer for each of those activities. And as always, you want to remember to include your references for every lab report that you type up. So now we want to look at the actual lab that you will be doing. So this is your laboratory sheet, and this is going to give you all the information you need. You can download this, it'll be easier to see it, but I'm going to show it to you through the experiment on, excuse me, through this section. So it's groundwater and surface water interactions. And so this gives you an overview of what you will be doing. Clean drinking water is vital for all human life. In this laboratory, students will learn how freshwater sources interact through the natural processes of the hydrosphere, all the water on the planet, and what happens to drinking water supply when our planet becomes altered by human activity. And so that's what you're going to be looking at for this particular lab. Some key so you need your goggles, your gloves, and your apron, which should come with your kit. Follow the link to the video, photograph results and submit, and a stopwatch is required. Okay? These symbols, if you see them, this is what they mean. So this is a warning symbol. This means corrosion. This is flammable. This means toxic. This means environment. And this means health hazard. So you know what those symbols are. Then it talks about the background information for this particular lab. Make sure you read through that. That's going to help you write your introduction for your lab report. And that just gives you a lot of information about groundwater and surface water. Now, these are the materials that are needed from your kit. So you need your clay bar, your sand, gravel, plastic cup, a plastic container, Kool-Aid, a two-piece aquarium tubing, two plastic tubes, three straws, a syringe, a disposable pipette, and a foam cup. The supplies that you need that are not in your kit are water, some tape, a plastic bowl or container, some scissors, paper towels, a permanent marker, and a timer. Okay, so this could be just the timer, either like a kitchen timer or the timer on your phone. It's perfectly fine. Important to know that items will be reused, so do not throw anything away. Between activities, you will rinse items such as sand and gravel over a plastic bowl or container placed in a sink to separate the materials from each other. The bowl will prevent any excess material from clogging the sink. You will rinse the syringe and aquarium tubing between activities and reuse them. You will also use the clay and Kool-Aid drink mix for multiple activities. So be sure to save these materials. Okay, very important disclaimer there. And we want to go through the safety. So we want to read all instructions for each laboratory activity before beginning the investigation. Follow the instructions closely and observe established laboratory safety practices, including the use of appropriate personal protective equipment. Do not eat, drink, or chew gum while performing these activities. Wash your hands with soap and water before and after performing each activity. Clean the work area with soap and water after completing the investigation. Keep pets and children away from the lab materials and equipment. The clay may stain your clothing and hands, so be sure to use care and wash your hands thoroughly after handling these items. In particular, you may wish to wear gloves and your lab apron while handling the clay. Okay. And so I want to stop sharing for a moment just to show you these things. Okay. So my sand was leaking. So I put it in a bag. But this is your bag of sand that came with the kit. And then this is your container that you're going to use for your reservoir. Okay. And then you have some plastic cups, your styrofoam cup, you have your bag of gravel. Okay. Your bag of gravel. And then your other things should have come in something looks like this. So you have your three straws, you have your clay. Okay, so you notice that if you put the clay in the container, okay, it's not, here, if I can do this so that you can actually see it. Okay, it's not as wide as a container, but it's clay. Okay, so you can manipulate it so that it stretches to be you want it to stretch straight across here. So you're going to manipulate it so that it does stretch. Okay. And then you also have, ooh, you have your pipette, disposable pipette, and your tubing. Okay. You have your syringe, should be in the packet. You have your Kool-Aid packet. This is for the experiment. Do not try to make yourself a pitcher of Kool-Aid with this. All right. You have another one of those tubings there. I'm sorry, and then you have these rubber tubings. Okay. All right. So we're going to go back. Share again my screen so we can go back. All right. So in your activity one, you want your setup to look like this. So you see how the clay bar goes all the way across? This is what I was talking about. And so you want it to be about a third. So you're going to kind of like mentally visualize your reservoir in thirds. Okay. And so you want this to cut off a third of the area that's going to be your reservoir. The rest is going to be your aquifer. All right. So the smaller section will represent the reservoir, the larger your aquifer. And you're going to take one of the clear plastic tubes, not to be confused with aquarium tubing, and cut it in half with a pair of scissors, okay? These two cylinders will model the wells drilled into the ground and reach the aquifer. So these are the wells. So you're going to take your plastic tubing here that looks like not your rubber tubing, but this one. You're going to cut this in half. That represents these two wells, okay? And then the rest of the information should be self-explanatory on how to set up everything else. But if you have questions at all as you're going through this lab, please let me know. Now you want to do activity 2. And for this activity, you will create a model of point source pollution, sorry. A large industrial plant is disposing of its waste material through a discharge pipe into a drinking water reservoir. You will see how these pollutants play a role within the water cycle and if an impermeable layer has an effect in blocking contamination of the groundwater, okay? And so this tells you how to set it up, okay? All right, so this tells you some disclaimers of how to set it up, how to clean it up so that you're ready for section 2. All right, so for this activity, so you have your sand here, and now you're using the rubber tubing, and then it shows you step by step how to set it up. Okay, but if you have questions, let me know. And again, you see how we're reusing the sand, the gravel, and the clay. And so that's why it's important that you don't throw these out. All right. So then activity 3, this is the non-point source pollution. So in this activity, you will see the effects of drinking water in 2 locations: a house on a hill where drinking water comes from a well confined under an impermeable layer, a house located downhill by a pond where the drinking water comes from a well in a permeable layer. All the land between the 2 houses is fertilized each year, and both homeowners want to know the effects that this potential pollutant, the fertilizer, has on the water source in the event of runoff from the rain, okay? And so it's going to explain to you how you're going to set all these things up and what you do for your procedures. So you want to write down your activity observations, okay? And then you have the questions that I gave you from the previous file, all right, that I read to you before. So disposal and cleanup, you're going to discard the activity components in the trash can and sanitize the workspace, okay? If you have questions as you're going through the lab, please, please, please let me know, all right? Don't want you to be confused. This is a pretty fun lab, exciting to do, all right? But let me know if you have questions. Here is where you're going to actually submit your lab report, all right? So I am going to go back to modules, and we're going to go to the next activity. All right, so that was your lab. So if we look at the next thing, you have the midterm exam. So you don't have like in module 3 where you had the quiz and the math assignment. You do not have that for module 4, but you have your midterm. So everything that you have learned previously, including what you've learned in Module 4, will be on the midterm exam. So make sure that before you take that midterm exam, if you have any questions, that you reach out to me and let me know. All right? And then we have the AI Design Preliminary Wastewater Treatment System assignment completion. So in Module 3, you had the directions for that, and you submitted that you understood the directions and everything. And so Module 4 is where you actually submit your activity. So you remember, it is a PowerPoint presentation that you are submitting. Very important that you have your 2 AI created drawings or diagrams, that you have your PowerPoint presentation, you include the title and introduction, the purpose of the preliminary treatment, your proposed system design, your drawings and diagrams created by AI, your justification of why your design is effective, potential challenges and limitations, and why the plant should adopt your design. Your recording should be 5 to 8 minutes, and you're explaining the system as if you're pitching it to decision makers at a wastewater treatment plant. You want to upload your video to Canvas or a shareable link using YouTube or Google Drive, all right? And so this is the module where you actually submit your activity, all right? So if you have any questions on that, please reach out to me and let me know, all right? And so that is all you will be doing for Module 4. So if you have any questions, as always, you have my email. You can reach out to me through email, or you can give me a call on the phone, or you can leave me a message. But if you have questions, please reach out to me. Do not have your questions go unanswered. All right, have an enjoyable Module 4, and I will see you in Module 5.